Hi, my name is Yabby, and this quarter I worked on scaffolded exercises. The problem space that scaffolded exercises is trying to address is the lack of resources that help intermediate web developers master writing professional front-end code in JavaScript. Using current tools like Chrome DevTools, as you can see in the image to the right, can be overwhelming. Intermediate web developers don't know where to start understanding the code, nor how to break up the code to progressively build their conceptual understanding. This leads us to our design argument, which is expert guidance and process management are needed for learners to know where to start and how to maneuver through unfamiliar code. This problem space is complex because not everyone has an expert that can tell them what to look at and how to navigate source code. So there needs to be a way to automate this process for any website. But for now, the goal is to automate this process for XKCD, a comic book website with an infinite scroll mechanism that continuously scrolls through one seemingly large image. My contributions focus on rebuilding the interface and system model. I identified flaws with the current interface and system model, created an updated user study and pre-post test rubric to better measure learning, and then ran a pilot study. And this study demonstrated the need for scope and context. So the previous interface argument stated to learn professional code, learners need expert guidance through variable value transformation and process management through the reverse call stack sequence. But only focusing on exercises with variable value transformation limits learning because not every piece of code will create a value transformation. We'll be skipping over code that assigns a variable or creates a function. But in order to understand how a variable value changes, learners need to understand all the helper function and any variable or function that is declared, because those are going to be building blocks to understand why a value has changed. So by skipping over all these other pieces of code, we aren't allowing learners to fully understand variable changes, which leads to the updated interface argument. To learn professional code, learners need expert guidance through well-scoped and contextualized exercises and process management through the reverse call stack sequence. So what does scope and context look like? Scope means small enough exercises that learners are able to focus and understand the granular details of the piece of code that is right in front of them without being overwhelmed. For example, this piece of code that updates map.cs as you see on the top left. But if we only focus on the specific piece of code we're looking at, we miss the context of where and when it happens in our source code. For example, map.cs happens within the function update. So we need to show the function that the code snippet is a part of. Another key part is that there are pieces of code that are just variable assignments or function declarations, like image being declared on the second code example. But learners also should see how the variable or function is being used, like image is being appended to map. So if there's a code snippet that is a variable assignment or function declaration, we need to show where it's being used. Now, the last part is that once a learner understands all those smally scoped exercises, learners need to be able to piece together how everything fits together as a whole by seeing a large scoped exercise. For example, in the next exercise, we see the image and append image within the scope of the if statement. And then the exercise next to that has the entire code for the update function, which includes the map.cs snippet, the image and append snippet, and the if statement. So now we can see that the function append happens within another function, map. So now learners can slowly build their understanding of those granular details of the code snippets by having small scoped exercises, but also see how everything connects together by using by having enough context, and they will be able to see the whole function. So now with the updated interface model, we can look at our system model. So if we look at the previous system model, it creates a call stack, which is an ordered list of code snippets from the source code in the order that they were called in. And with this, we can go in the reverse call stack order to create our exercises. And this call stack you can find in runlog.js file. And then the exercise generator you can find in findexerciseorder.js file. So the previous exercise generator, it would loop through all the snippets of the call stack and only select the call stack, the snippet with the DOM object. But this is a system flaw because if we only focus on exercises with value transformation, we're ignoring any piece of code that doesn't have a DOM object. And as you see on the image to the left, this call stack snippet that I've shown doesn't have anything that has a DOM object, so all of this code will be ignored. So instead, for the new system model, in order to update this exercise order generator, we just need to iterate through all the snippets in the reverse call stack order and just remove all of the conditions that checked if there was a DOM object. But we also need to make sure that each exercise that we generated are well scoped and contextualized. And this is the tricky part, and it's still a work in progress. So now I created a study this quarter where my main focus was answering these questions. How does process management through exercise presented in an intuitive reverse call stack order help intermediate developers learn about variable value changes in professional code? Also, what type of exercise format provides greater learning on variable value changes? Is it the variable value transformation exercises in the previous interface model, or is it scope and context exercises in the interface model that I'm arguing for? And then also, is scaffolded exercises biggest risk the exercise order or the exercise format? So to test these questions, I created a user study that allowed each user to have 3 rounds of code exploration of the XKCD website. The first round used Chrome DevTools, the second round used the variable value transformation exercises, and the third round used the scope and context exercises. I ran this pilot study on 2 intermediate developers. So I tested each user's learning by having them answer these 3 questions on the left with the pre and post test, and then I assessed their learnings using the rubric on the right. So these are some of the findings that I found based off of quotes during the user exploration and just my own observations. And I'll just focus on the one in the middle. It says, after looking into the exercises that deal with initializer code, one user said, I don't think this is relevant. And this is because the algorithm that produces the exercise with the variable value transformation, that was the second round of exploration, this algorithm didn't strictly follow the reverse call stack sequence. But once the user saw the exercise in the third round of exploration that was around scope and context and that strictly followed the reverse call stack sequence, they were able to see how everything connects a lot better. So this demonstrates that working backwards is helpful to understand the granular details while building a larger conceptual understanding of the source code. Now I'll speak on some findings based off of the user's pre and post test answers. The first is around understanding variable value changes that was being tested in question 1. For both users, the second round of exploration resulted in 0% increased learning in how the keyboard/mouse inputs change the DOM. And it was only through the third round of exploration, the one that had the scope and the context, that round allowed both participants to reach 100% understanding on how the variable value changes. So this shows that focusing on exercises around variable value transformations limits learning. Another key insight was around question 3, which tested a user's ability to write code that will replicate the observed website. So the first participant had a very basic understanding of the system, but then by seeing the context of the code snippets, it made everything click. And that happened on the third round. Versus the second participant had a clear understanding of the code, the source code by the second round, because those smaller scoped code snippets made it easier for them to dive deeper and analyze the code. And this kind of shows that our user group of intermediate developers might be more nuanced. They lie on a spectrum. There might be a developer that is a little more on the expert side of the spectrum that will learn more through smaller scoped exercises, and they'll be able to kind of piece together a conceptual model purely by those smaller scoped exercises. But then some of the intermediate developers that lie more on the beginner side of the spectrum might learn more by having smaller pieces of code in a context that allows them to see how everything fits together. So now these are the general findings from this pilot study, and there are some clear limitations to this study, such as it only having 2 participants. But the findings show that there's a clear increase in learning after the third round, which presented exercises focused on the scope and the context, rather than the variable value transformation that happened in the second round. So the key learning from this is that to provide expert guidance, we need to focus on scope and context. And some next steps would be to test, what do well-scoped and contextualized exercises look like? Is this a one-size-fits-all exercise template? Does our user group, since our user group has some nuances, is there a way that we can tailor these exercise templates? And how can we automate this for any professional website? And then there's a few other questions that we can also dive into in the future. So key takeaways is that our design argument still stands. Our users need expert guidance and process management. And then we've changed our interface and system argument so that expert guidance should be implemented through smaller scoped exercises with enough context. Thank you.